So in this problem, we have some information about a tornadic event that happened in 2013. So down below, you'll see the histogram representing the length of time these tornadoes were on the ground, or excuse me, the length in miles, not time, but the how many miles they were on the ground. And we know that the mean length of the tornado from this 2013 event was 3.689. So it was on the ground for 3.689 miles, and it has a standard deviation of 6.883. Now, the first question here says, let's use the normal model to figure out what proportion of tornadoes from 2013 had a length of less than 5 miles. So if we're using the normal model, I'm going to sketch my normal curve here. And we're told in the problem that the mean length is 3.689 with a standard deviation of 6.883. And we're looking for the proportion of tornadoes that were less than 5 miles. So less than 5 miles. So 5 is over here to the right of my mean. Now remember, my x-axis here is the length in miles. And I want to know what proportion of those tornadoes were less than that. So I'm looking to shade to the left over here. So my probability question says, what's the probability that I have a tornado on the ground less than 5 miles? And we're going to use our normal calculator to find that answer. So switching back to the calculator, we have a mean that was given to us in the problem of 3.689. So we're going to change that to 3.689. We're going to change our standard deviation to 6.883. We are looking to change this symbol to less than, and it's 5 miles, so less than 5 miles. So I have everything entered into the calculator that I need, and when I hit compute, you'll notice that it says 0.5755. Okay, so the area under that curve is representing 0.5755. So interpreting this, we would say that the proportion of tornadoes that were on the ground for less than 5 miles was 0.5755. Or the percentage of tornadoes that were on the ground for less than 5 miles is approximately 57 or 58%. Now, if you'll notice, I'm going to make this bigger so hopefully you can see it. This is the histogram we were referring to at the beginning of the lesson. And this is the actual data. So this is really how long, the length that these tornadoes were on the ground. And here, the very first bar of this histogram is representing the tornadoes that were on the ground from 0 to 5 miles. So notice here at the top, this is a relative frequency histogram. So I should be able to estimate the height of that bar is, I don't know, somewhere around, let's say, 0.78. So in reality, the proportion of tornadoes that were on the ground for less than 5 miles is really closer to 0.78 or 78% of the tornadoes that were on the ground. 78% of those tornadoes on the ground for less than 5 miles. Now compare the 78% of reality with the 58% of a model. So remember, this is just a model. And you'll start to notice, I hope, that the model that I used did not accurately predict, did not even come close to predicting the reality. And why do you suppose that may be? Well, hopefully you'll see the key word here is that I have a normal model that I was using. And yet, if we look at the histogram here for the actual data would be considered skewed right. So how can I apply normal model stuff to skewed data? We learned a long time ago that if I had skewed data, I dealt with it in one way, and I was only supposed to use normal stuff when my distribution was normal. This is an illustration of what can go wrong if we have a sample set, or if our population, I mean to say, if this population is skewed and yet I tried to shove it in a normal model. It didn't work out right. And that's going to be a caution for us as we move into the future.